Hello, in this lecture we will discuss solution of quiz 3. Okay, so from question number 1, this is the question. In this question we need to calculate V1 and V2, and V1 is here and V2 is here. Okay, so the idea behind this question is for the diode. Okay, so this is the diode symbol and this is anode and this is cathode. Okay, so the idea, suppose the voltage across the diode VD, or we can say the voltage which is VAK. Okay, so this VAK, that is voltage across this diode, which is greater than 0.6. okay, so diode will conduct. Okay, diode will conduct, diode will conduct. Okay, otherwise, that is voltage across VAK, that is voltage across the diode, which is less than, suppose, 0.6, the diode will off. Okay, this is the idea. Okay, so from this figure we can calculate this V1 and V2. So this for the D2, this is the cathode terminal for D2. Okay, so because the cathode terminal connected with the positive supply, that's why the D2 will off. Okay, or D2 will not conduct. Okay, and because of this D2, there is a open circuit scenario. Okay, there is a open circuit, that means there will no current in this branch. Okay, the I, suppose the the current which is flowing through this 10k, so it will be 0. This is the idea. Okay, that's why this 6 volt which appear at this point, that is V1. Okay, so for V1 we have voltage which is equal to 6 volt. Okay, fine. Now the second point is okay, so the second point is for V2, we need to comment at this particular diode, that is D1. So this anode terminal which is connected to the positive supply, and definitely at this point there will be a less amount of voltage, because it suppose यहाँ पर कोई करंट फ्लो नहीं भी होगा, तब भी आपका 3 वोल्ट यहाँ पर अपियर होगा, और इस केस में जो वोल्टेज अक्रॉस VAK है, that is voltage across anode cathode है, it will be greater than 0.6. so no problem with this. Okay, so the from this concept we can say the diode D1 which is on, and because of diode D1 on, the voltage V2 which is equal to 6 minus. Okay, so 6 minus the diode, we can replace this diode by a battery, that is like this. Okay, so this is amount is 0.6, so we can say this is 6 minus 0.6, it will be 5.4. so for this question A will be the right answer. Okay, that is V1 equal to 6 volt and V2 equal to 5.4 volt. Now question number 2. So we need to identify the VI characteristics of tunnel diode, and we know that the tunnel diode shows negative resistance. This is important, negative resistance, and from this figure you can easily find the correct answer, which is B. Okay, this particular part shows negative resistance. Okay, so this is negative resistance reason. Now question number 3. Assume that D1 and D2 in the following figure are the ideal diode. Ideal diode, that means the characteristics of ideal diode, which is like this. Okay, so this is voltage and this is current I. So in the case of ideal, there is no current for V less than 0, and maximum it will behave like short circuit after V equal to 0. Okay, so we required the current I which is in this branch. Okay, so this is very simple concept, no problem with this. The current, the flow and the direction of current in which is like this for this circuit, but we required the current through diode D2, and और करंट कभी भी आपका कैथोड से एनोड की तरफ फ्लो नहीं होगा डायोड के केस में. तो इसको हम इजीली इस कॉन्सेप्ट से यूज कर सकते हैं कि द डायोड, सपोज दिस इज द सिंबल ऑफ डायोड, सो इट द करंट फ्लो इन दिस डायरेक्शन, दैट इज एनोड टू cathode. This is important. Okay, so correct answer for this question is option number A, that is 0 milliampere. Okay, next question is question number 4, and the question is, this is the voltage regulator circuit. Okay, and the power rating of the Zener diode is 400 milliwatt. Okay, this is important point. So the power for a Zener diode which is given, and okay, and which is equal to 400 milliwatt. Okay, and what is power? Power is the product of voltage into current, so Vz into Iz, and this is equal to 400 milliwatt. Okay, what is Vz is given, Vz is 10, so we can calculate this Iz, which is equal to 400 milliwatt divided by 10 volt. Okay, so this is equal to 40 milliampere. Okay, this is important. So we have Iz, which is equal to 40 milliampere. We required this RL. Okay, so the RL, that is we required actually the voltage across RL, and which is equal to Vz, no problem with this, and the current through RL. Okay, which is IL, suppose. So we can calculate IL with this concept. We have total current I here, the Iz here, we have Iz which is equal to 40 milliampere, so we can calculate IL. So what is I equal to 20 minus, so the voltage at this point which is 10, so 20 minus 10 divided by 222, and it will be 45.045 milliampere. Okay, so easily we can calculate this IL. So this current is 45 and this current is 40, so the IL will be 0.045 milliampere. Okay, so now we have IL which is equal to 5.045 milliampere. Okay, so from this we can calculate RL. So RL is V divided by, or Vz. Okay, Vz divided by IL. So Vz is 10 divided by 5, so it will be nearly equal to or approximately 2 kilo ohm. Okay, so the correct answer is B. Now question number 5 is, the diode is given and the threshold voltage which is 0.6, that is the voltage across anode and cathode. So this is anode side and this is cathode, and voltage across anode cathode which is given 0.6. Okay, so we require 0.6 volt for conduction of diode. Okay, this is the point. The given V1 is 10 volt and V2 is 0 volt. So this is very interesting question. So this is V1 is 10 and V2 is 0, so D1 will be off. D1 is off. Okay, and D2 will conduct. So the equivalent circuit will be like this. We have 10 volt, then 9.5 kilo. Okay, then this is the VO terminal. Okay, and then D2 will conduct, and this is a p-type semiconductor. It will consider as a positive of the battery, positive terminal of the battery, and the n-type which is negative terminal of the battery, and then 0.5 kilo ohm resistance, then 0 volt. Okay, 0, that is ground. Okay, so we can find the current through this circuit, that is I. So I is the VAT is 0.6 volt, so the I will be 10 minus 0.6 divided by total resistance 0.5 and 9.5, which is 10k, so it will be 0.94 milliampere. Okay, we require this voltage VO, so VO will be VO, that is this potential 10, that is 10 minus the potential across this 9.5k, so this 9.5k multiplied by I. So I is given, okay, we have already calculated, so this is 0.45, so 9.45 into 0.5, 0.95, so it will be 8.93. okay, and the value will be 1.07. so the correct answer for this question is option number C. Okay, option number C. Now for question number 6, again similar type of question, but the condition is differ. This V1 is 10 and V2, which is in this case 5. So again D1 is off, no problem with D1. Why D1 is off? Because this is 10, okay, 10 which is connected to the anode terminal, and in and the cathode terminal which is also connected with the 10. So now we require 0.6 volt for this for the conduction, so that's why this is not possible to conduct. That's why D1 is off, but D2 maybe D2 will be on. Why? Because the cathode terminal which is connected to lower potential as compared to anode terminal. So the equivalent circuit will be like this. This is 9.45k, this is 10, then VO, okay, and this is 0.6, okay, and then 0.5k, and this is 5 volt. This is the difference, okay. So again the current in this branch, which is suppose I, so we can write this is 10 volts, so we can write minus 10 plus 9.5 and plus 0.5, so this is 10, okay. So 10k into I, okay, then minus 0.6 this battery, and minus okay, so this is positive terminal, so this is plus 0.6, then 5 volts, so this is, which is 5, okay. You can consider like this, this is 5 volt battery, and here this is 10 volt battery, okay. So start from this point, so that's why this is negative sign here, and for this case this is positive sign, there is positive sign, and this is equal to 0. So from this equation you can calculate I, so I which is equal to 0.44 milliampere, okay. And similarly in the previous case we have this we have calculate VO, so VO which is 10 minus 9.5k into I, so here I is 0.44 milliampere, so it will be 0, it will be 0, it will be 5.82 some, okay, nearly equal to 8.52. so the correct answer is C, okay. Now the next question, in this question both diode which connected to the ground, that is 0 volt, okay, so both will conduct, D1 on and D2 on, okay. So the equivalent circuit will be like this. So there is a VO and 9.5k this branch, so this is the node, and this is the 9.5k branch, and which is connected to the 10 volt battery, so this is 10 volt. And similarly for this branch we can write equation, we can draw equivalent circuit. So the D2 so this D2 will replace by a battery, positive negative, and the value is 0.6, and the resistance will be 0.5k. and similarly for D1 0.6 battery, no problem, and the resistance 0.5k. You can ask doubt if, no problem. So this is VO, so this is simple circuit, so we can calculate VO. So VO minus 10 divided by 9.5k, 9.5k plus the volt current in this branch, that is VO minus 0.6 divided by 0.5k plus VO minus, that is in this branch, VO minus 0.6 divided by 0.5k, and from this equation you can calculate VO, and this VO will be 0.842, okay. From this equation you can calculate. So the correct answer for this question is option number D. Now question number 8. Okay, so in this question, this Vy, that is threshold voltage, is given, which is equal to 0. Okay, so for the positive voltage it will conduct, and for the negative voltage it will not conduct, that is open circuit. Okay, so the input is 20 volt here, initially 20 volt, so 20 volt, that means it will conduct, so it will behave like short circuit. Okay, diode will behave like a short circuit, so it will short like this. Okay, so you can calculate this VO which is exactly equal to Vi. Okay, so for Vi positive, okay, this output voltage which is equal to input voltage. Okay, and for in this case, that is Vi is negative. Vi is negative, that means it will behave like an open circuit. Open circuit, that means there is no current, and so we can say the total voltage. Okay, so this is open circuit voltage, and which is equal to 5 volt. So if Vi is less than 0, the output voltage which is equal to 5 volt. Okay, so from option we can choose the correct answer. So for positive voltage, that means this cycle output is 20, and for negative voltage the output is plus 5, that is this point. Okay, so correct answer for this question, which is option number D. Very interesting question. Okay, now the question number 9. The D1 and D2 are ideal diode. We required current I1 and I2. So the ideal diode and the D1 which is connected. Okay, so the cathode terminal of the D1 which is connected to the positive terminal of the battery. So D1 will not conduct. Okay, but there is a chance to conduct D2. Why? Because this anode terminal which is connected to the 5 volt battery, and this cathode terminal which is connected to the 3 volt battery, so it will conduct. Okay, and the equivalent circuit would be like this. The D2, so D2 will conduct, so it will behave like short circuit. Then 3 volt battery here. Okay, and the 500 ohm resistor, and 5 volt battery. Okay, this is 3 volt battery. So we can calculate this I2, and the I2 equal to, which is 5 minus 3 divided by 500. Okay, so it will be 2 divided by 500, and we required the answer in milli, so multiply by 1000, and this is in milliampere, so this is 4. Okay, so the correct answer for this question is 0. Okay, so I1 is 0 and the I2 is 4 milliampere. Okay, so the correct answer for this question is option number A. Okay, now question number 10. It is based on voltage regulator circuit. Okay, so, and for the Zener diode, the current is limited to the in the range of 5 to 100 milliampere. Okay, so we require the load current range. Okay, this range. So first we need to calculate this I. Okay, and then this IL. So the I will be 6.5 minus the potential at this point, which is equal to Zener potential, that is 4.8. so 4.8 divided by 12, so it will be 125 milliampere. Okay, so now we have I equal to IZ plus IL. Okay, so we required IL, so IL will be IZ or I minus IZ. Okay, so here I is 125 milliampere. 125 minus what is IZ? IZ minimum is 5, that is my 120. So IL maximum, which is 120, and in the case of maximum IZ, there will be IL minimum 125 minus 100, that is 25. So option number B will be the correct. Okay, fine.